Hello, this is the Blast Report podcast on all things blasting. My name is Thibaud with New Wave Consulting, and I want to thank all the drill and blast teams along with those supporting them who are out there on the pattern. The production team at Blast Think and I would like to welcome you to today's episode of the Blast Report podcast. This episode of the Blast Report podcast is brought to you by Detecht. Detecht is a specialized engineering firm focused on third-party vibration monitoring. Historic structures, critical infrastructure, and nuclear power plants are included in Detecht's long list of projects where compliance was absolutely key. Not only does Detecht install and maintain an array of instrumentation, but they are also a certified dealer of White Industrial Seismographs. It's their goal that all dynamic monitoring solutions be at your service nationwide. This women-owned and family-operated business traces its roots back to our guest, Cathy Amione, and would like to take this opportunity to thank her for her mentorship and support over the years. So contact Detecht for applied research on your next project at www.detecht.com. Well, I got Cathy Amione here. Thank you so much for coming on the show. I really appreciate it.
You are very welcome. Pleased to be here.
I wanted to get you on here, and this is a second attempt on a recording, and we had such a lot of knowledge shared on how you got into the industry and what the trickle down effect of so many things you were a part of ended up being what we deal with on a day-to-day basis with blasting. So would you mind kind of starting out with what was your first experience with explosives, and were you even ready for it or wanting this to be a career that you're looking back and saying, oh, wow. So what was that start?
That's a great question. I just fell into it like a lot of people do. They just find themselves in that situation. I was in Chicago as a single mom with two little baby girls, and I had no idea what I was going to do with a degree in mining engineering. And I just happened to have an uncle there in Chicago who said, why don't you go to Northwestern University and talk to the department chair? We're good friends. We've known each other for years. And just tell him Jack Taylor told you to come. So I did. I marched right into the department chair's office, and I'm Jack Taylor's niece, and I happen to have a degree in mining engineering, and I'd like to look at an advanced degree, a master's degree. He popped up, grabbed my hand, flung open the door, went in to see Dr. Dowding, and flew open his office door and said, I've got a mining engineer for your project. And of course, Chuck was elated. I didn't know what was going on.
Right place, right time.
Absolutely. It just happened that Chuck Dowding had some money, a grant from the U.S. Bureau of Mines and Dave Siskin to look at the social, legal, and economic impacts of the OSM regulation. And that OSM Z curve, of course, was adopted from the Bureau of Mines suggested criteria. So I didn't know about that, but that was where I was headed. And he happened to need somebody, a mining engineer, who would actually go out into the mines and be able to look at what the cost structure was. It just happened that at Northwestern University, to become a full professor, you have to graduate a PhD student. And he had not had that happen. It didn't look like he was going to get a PhD student because a lot of his work is in rock mechanics and mining. They say he was elated. So he made it.
Went from just being maybe a master's to...
It ended up to the PhD, yes. And the dean of engineering happened to come to me too, Dr. Maury Fine, who was also a very good friend of my uncle's, and came to me and said, well, why don't you stay for a PhD? And I thought, well, yeah, I'm try it, see if it works. It worked out beautifully. Everything fell into place, and it was perfect. Now, in those days, I was assigned to go out into the coal mining industry because the OSM regulations, as people might know, was part of the Reclamation Act. Here it was
71 or 75. I think it was 75, right?
Yeah, it was part of the 1975 Mine Reclamation Act, which was geared to the coal mining industry. There were 7 provisions in that act, and one was to regulate vibrations, because there were so many complaints in Appalachia about high structural response and all these problems with damaging structures and so forth. So they adopted that criteria because it used to be most of the coal mining states had 2 inches per second regulation without any frequency criteria. It was just across the board. Everybody had that.
Any air overpressure?
Yeah, I think I can't remember what the air over. I think it's probably more like 138.
Okay.
It might have been a little higher.
So there was something involved in that as well.
I think there was. So with the OSM, with the regulation setting forth the Office of Surface Mining to oversee these regulations, those regulations were then enacted, part of the Reclamation Act, to lower, of course, the vibrations at lower frequencies. Okay, so instead of 2 inches without any frequency dependency, of course, we all know the Z curve goes down to 15. When we're at 15 hertz, it goes down to 0.5. So it was for the lower frequencies, which coal mining generates, they were more regulated, the lower limits. So the coal mining industry, of course, balked and complained and were very upset about this. So they went to the Congress and they went to the legislature and tried to stop that, saying that it was going to cost more money to blast at lower vibration limits, at the low frequencies that coal mining generates. And so that cost project that Dave Siskin put forth to Northwestern University was a considerable amount of money for a lawyer, an economist, and a mining engineer to work together on this new cost impact. But the mining engineering position meant that you had to travel out to the coal mines for one whole summer. It was 4 months, and just from all the way from Pennsylvania down to Alabama to find out what it was going to cost those operations to comply with the lower limits. Was there a cost impact? Because that's what the coal mining industry said. It's going to cost us more to
They'll
blast
put
the
us
lower
out of
limits.
business. And
Yeah, I think maybe.
that's
I don't
what their
think.
claims were.
Yeah.
So when you went there, what were the parameters you were looking at in the cost?
I didn't know at the time because I knew nothing about cost of mines. I knew nothing about blasting. The first thing I did was work with Ensign Bickford because they were the ones that purchased the non-L system at that time in the mid to late 70s when the Swedish Tectonic Institute Research Center came with their non-L system to the United States asking who would take it. Ensign Bickford said, we'll give everybody. Nobody knew what it was all about. So Ensign Bickford did. And that's the first place I started out because I knew nothing about coal mining. I had no idea about blasting. And I ended up in Evansville, Indiana, with a few people who are still now in the industry, learning about non-L systems. And so it was non-L that opened up the doors and said, "Come on with us. We'll go to Amex. We'll go to Peabody. We'll go to all these mines so you can see the system and see how it works." And then that's where I started my connections. And we again, in those days, of course, we had dial-up phones, and we didn't have any resources other than what is called the Keystone Manual. The Keystone Manual is a book of all the mining companies, all the coal mining industries companies, all their mine managers, their phone numbers, and so forth. So I took that book, and after I met with after I learned a little bit about coal mining and initiation systems, I took that book and started looking for coal mining operations that would allow me to come into their operations for a day or two and learn about their cost structure, how they were blasting, what they were doing, facing these lower limits. And the first mine I went to was in Southwest Virginia. And I'll never forget going to that mine. And I called that mine manager and he said, "Yeah, come on." I thought,
The first one.
Yeah. I thought, what kind of mine manager is allowing this woman who knows nothing about coal mining to come to the mine? But I went and I asked him, I said, "Why did you let me come?" He said, "But I was curious what a woman was doing in this industry." And I had to laugh, and he was wonderful. He showed me around. He had a big drag line, showed me all about the blasting and how they use the drag line and what they did for them, opened the books. I mean, this is what it's costing us to do this now.
Wow.
And so that was just the beginning. And then I went to so many other mines and every place I went, the explosive distributorships, I would work with them often also because they had access to all the mines. And they were, I don't know if it was a curiosity about who I was and what I was asking, but they wanted to tell their story.
I guess it was also on their side as well, because they wanted to make sure that these new laws wouldn't negatively impact them.
Absolutely. Absolutely. But the thing at that time too, we were moving away from ANFO. We were starting on slurries and then emulsions at that time. It wasn't all that summer, but I could see there was a trend in moving away from certain types of products, initiators, and they knew this non-L system was something that was a lot more reliable than electric blasting caps, a little more accurate. So we even looked at accuracy and that sort of thing. We did some studies. But when we sat down and really looked at what they were doing to comply with those lower limits, yeah, they started decking. They started doing different timing patterns, different patterns to adjust to lower costs. And lo and behold, fragmentation was better. Frequencies could be increased. And so throughout that summer, we started to look at some of the things that they would do. And the cost came, it was a cost savings. It actually was a cost savings because the blasters would have to look to see what were we wasting. We were wasting a lot of it. We were overshooting. And they could bring it down and have the same results. And it was the next summer then that I proposed for the PhD on doing a fragmentation timing study and that sort of thing. The high-speed cameras, we'd gotten a big grant from New Mexico, $5 million grant. And
so before you went into the fragmentation, about how many mines were you able to visit in that 4-month span, and how were there so that's one question.
That's a good question.
About how many mines, and then the other question was how many weren't wanting you there?
None of them did not want me there.
Wonderful.
It was absolutely amazing. They wanted somebody to come ask that question and say that there's an avenue to work with this and to improve the blasting even at lower powder factors. And so I think they understood that it was an important endeavor because they were faced with it. It took a few years for it to actually pass Congress, but it actually did. They knew it was coming. So that I think was important. And they were very open.
You went from Pennsylvania all the way down?
All the way down to Alabama. I think there was about 45 mines that I was able to see every week throughout the 4 months. And it was amazing. And again, I would call some of the mines, but I would go with the explosive distributors because they could get me
in the door a little bit.
Exactly. Nelson Brothers, Dugan Nelson, I remember Dugan. His son had a helicopter. They had a helicopter to run parts. And so for Nelson Brothers, it was the original Nelson Brothers out of Alabama. And his son just said, take her in the helicopter and take her out to all the operations. The doors just opened. It was amazing. I was able to see multi-seam with these long, big drag lines to see exactly how they were operating. I think the most interesting was the steep slopes in Kentucky and Virginia, and steep slope lining, because part of the Reclamation Act was so that you can't throw any material downslope anymore into the hollers, you call them. And so that was hard because they used to throw all their overburden downhill. And so when I looked at that and I thought, oh, what can I do? So the next summer, some of these problems cropped up. And so I developed an education plan so that we could actually change some of the direction of the initiation so we could keep them on the slopes. So with high-speed camera and the non-nail system and just decking holes and minimizing and changing the pattern and sequence of initiations, that was the big goal in steep slope. We were very, very successful. And
so these kinds of, it almost became hand in hand with creating a lower vibration was,
modifying
the efficiency.
Yeah, absolutely, very much so. I remember one slope, probably the steepest slope in West Virginia. We did a little study. They let me change things. We had the high-speed cameras. We take the non-nail system and make little bow tie tubes and put them on stakes so we could actually see the delay timing and look at the errors associated with timing. We know they are, but they're not like electric. And so we made this little pattern, and I made the pattern on the bench so that we'd started on the upslope part, and then with a V pattern when we came out, and it went well. I mean, I just made this up. I mean, it was intuitive at that point, and it looked good. We shot at 3:00 and shift change, and it looked good. The pile was good. Went back to the hotel. Came back the next morning to see how things went. Saw the mine manager, and he said, "What did you do?" I thought, "Oh, am I in trouble?" I said, "What's wrong?" He said, "Well, I started to excavate this, and usually it takes them until from 3 or 4 o'clock in the afternoon to about 5 o'clock the next morning. They were done by 10 o'clock at night. It was so well fragmented.
Yeah.
It was so well. They had no idea this would happen." He said, "I had nothing for my union guys to do for the rest of the night." I said, "That's a good thing."
It's a good problem.
So we had those kind of feedback. And I thought, this is fun. I really enjoyed doing that.
When it came to, so the introduction of the non-L system, the non-electric system, almost kind of came hand in hand with the Z-curve. So it was almost like it helped the sales and adoption of that technology.
It did,
Okay, I didn't
absolutely.
know that. All right,
Yeah,
interesting.
because the other Orca and Dino and some of the other, in those days we had a lot of manufacturers.
Mhm.
They weren't ready for that kind of transition. But Ensign Bickford took the lead and said, "We'll try it," and it was amazing,
Yeah, it took. I mean,
absolutely amazing.
the impact still to this day. I mean,
Mhm.
so on that other note, when you, I mean, the world is your oyster at that point with how to connect the non-electrics and what direction to pull up. They were already probably pulling in certain directions of a shot, right? I mean, that knowledge already existed. But what were some of the new tricks that were going on at that time that was quite new, other than the fact that you were already using an entirely new different type of product? Was there something else you can recall on the tricks there to reduce the vibration?
Well, I think one of the biggest impacts that happened as I became a professor and started doing more work out west where I lived was with the large coal mines that started up in the 80s. And they were huge. I mean, nothing like what we had back east, big coal mines. And to deal with, and the rock was a little different. It was
Like
a
the
little
Powder River
softer,
Basin?
the Powder River
Okay.
Basin, the whole area there. And trying to figure out how to implement the non-L system and new timing. I think we did a lot of timing studies. We did some timing studies to mitigate NOx, orange smoke. And what we saw with these big, I mean, these were half a mile long, these big shots. You know, they would go eight rows back and go, and then we were using emulsions with some sensitizers, mostly little glass beads. And we could see that there were some issues. There was some sympathetic detonations, there was some orange smoke and that sort of thing. And then we started looking at the timing. And the timing that was given to them by other experts was going really fast down the face and then waiting for 400 milliseconds during the second 400 milliseconds. And we thought,
Or the cast.
yeah, the
Or
cast,
the-
yeah, so that they were about 32% efficient in the casting. And it just was causing all kinds of problems. The orange smoke was a problem, and the fragmentation the back brake was horrible, that sort of thing. So we did some signature hole analysis with the Ensign Bickford at that time. And we realized shooting down at 9 milliseconds or 8 milliseconds, whatever it was, down the faces was just way too fast. And so we did some timing. Timing was a big issue for that. And we slowed it. We brought it up to maybe 27 milliseconds down the face. And then we would shorten it going back. 150 the first 2 rows, 200 the next, 250, and then 400, 300, and then 400. No more than 4 rows. No back brake, no orange smoke. So it was just a matter of doing that. That was more of a timing study at that time in the late 80s and early 90s. And so it was really perfecting the timing and the initiation sequence to mitigate some of these effects that we needed to get rid of. And fragmentation was good. I think we lowered the efficiency for throw down to 31%, from 33 to 34 to 31. It wasn't much.
But that was later on,
Yes,
after you had already
right.
moved up to New Mexico.
Exactly.
So-
exactly. But
Okay, so let me backtrack a little bit. When it came to the Z curve and the adoption there, your influence in that study and the results, it showed the lawyers and the government that yes, this piece of legislation can be adopted, which it wasn't intended to be law, right?
that is correct.
But it actually worked. And so was everyone happy? How did that kind of play out? You know, the lawmakers are happy. It's actually working to help efficiency. The mines were happy, or?
Yeah, by the time we got that cost study to the Bureau of Mines and made a large report, and that report went to the Bureau of Mines, and that Bureau of Mines then, the issue here was the fact that the Bureau of Mines had done in 8507 their research on structure response, and then came up with the safe blasting criteria. It was not regulation, it was recommended, but it was going to be adopted for regulation. And so the Bureau of Mines realized that that was going to be a problem because they're not a regulatory agency. And for them to have submitted research for that, the coal mining industry pointed the fingers to them and said, you shouldn't have done this. You know, you're the reason that it's going to cost us a lot more money. But that's when the Bureau of Mines realized that they were in trouble, because President Clinton was looking for agencies to
Eliminate.
eliminate, right, to reduce government spending. And I think the USGS was one, and the Bureau of Mines was one. So there were quite a few of them. Of course, the USG, as pointed to the Bureau of Mines, said take them first. And so they knew that they were up for dissolution. And so this is one of their last attempts, I guess, to show that even though they did this research, that it still was good for the coal mining industry. I don't think it got around to the coal mining industry. I don't think they understood that. It never did come up into the hearings. And it was sort of a last-ditch effort that just didn't make the impact that they hoped it did. And so in 1995, we lost the Bureau of Mines, which was sad because they were a wonderful research agency and they had a lot of impact on the mining industry as a whole. So, and then OSM kind of took over a lot of that.
When it came to your path after this initial project, what was your next step? You stayed, and that ended up being your PhD.
Correct. Yeah.
You did that over how long of a period?
That was the next year is doing that. So I think it was a 4-year project, program. The first 2 years taking courses, the end of the second year going out in the summer and doing the work for Dave Siskin and his crew, and then making the report, and then realizing that I needed to do something more than just that for the PhD. And that was the second summer doing all the studies, fragmentation studies and timing studies. And then I was done. So at that time, that was 1980, the end of 1980. So 1981, I came to New Mexico Tech in January. And
that's when you said, I got to go do it on my own?
That's right.
What was the story?
That's right. That's right. Then I thought, it's a great university. I interviewed on a lot of the universities, and I'd never heard of New Mexico Tech, and I interviewed at all the other mining schools, and I really liked the environment there. Small university, very dedicated.
You didn't like us Rolla guys?
I'm trying to think. Oh, I know. Well, it's funny. You should say that because I looked at Rolla doing my PhD, but I know this is kind of crazy, but as a single mom with 2 little girls, family housing wasn't available to me because I was divorced.
Oh, really?
And they wouldn't let me have family housing. And if I didn't have family housing, I couldn't have afforded it. So it got to the president. So I just said, no, I'm going to stay at Northwestern. And he wrote me a letter saying, we'll make an exception.
At Rolla?
Yeah, Rolla.
But you had already...
I'd already decided to stay at Northwestern.
Yeah, was a sour note in your mouth. But that's interesting how those kinds of dynamics, those social dynamics,
it changes
your life.
Absolutely.
So much,
But, you kind of paved the way for people like single mothers and women. And if I look back, probably I have made people make some decisions that they probably hadn't thought of.
Any off the top of your head?
Oh,
you can think of?
I'm trying to think.
Because that's a pretty significant one.
Yeah.
There.
Well, I think it's, I think when I was a graduate student at Michigan Tech, of course, all our spring breaks, we went out west here in Nevada and a lot of places to go visit mines. And so I think the population of the mining and geological engineering students, there were probably about 30 of us, 3 women and the rest men. We could not go underground. We weren't allowed to go underground. Wow. So we go to visit these. No, yeah, women couldn't go underground in the 60s, in the early 70s. We weren't allowed because it was a superstition. There were a lot of workers from foreign countries who thought if a woman entered a mine, surely there would be a collapse. And that was true. I knew that. I experienced it. So 3 of us women had to sit on the surface while the guys went underground, and we had to listen to a boring geologist about geology. But that's the way it was. And my first job in Canada, when we left Michigan Tech, worked for an underground and surface mine, and I was assigned to go underground. My husband was a mining engineer at the time, and he was a mining engineer that worked in the mine planning and that sort of thing. And I, as a woman, was given half the salary that he was given because, your husband makes plenty of money. You don't need the full salary. Yeah. So in those days, this is in Canada, an underground mine, and I accepted that. It was something we had to accept in the 60s. And then I had to go underground. The mine captain from Germany, Ernie Winkel, I'll never forget him, was not a happy camper. He did not want a woman going underground. Again, the same thing. You're intruding on men's territory. And, but I had to do it. He let me do it. He was not happy. I know every morning we'd have a meeting with all the staff and, to talk about what are people going to do that day. He would just growl at me. And it didn't bother me. It was okay. I was dumb enough. I didn't know any better. By the end of that first year that I worked, I decided to stay home and start having a family. And so I gave my resignation. Guess who the first person who came to me just said, "I'm sorry you're leaving"? Ernie Winkle.
Ernie Winkle.
He was really
Yeah.
really disappointed. Yeah. And so those are kind of things that, you put up with over the years. And
Right.
it's okay, but you just keep going.
At first, that's kind of the norm, and then now you see the difference in how it is now.
Very much different. Very much different.
There's still progress to be made as well, but
There is. But being a professor at New Mexico Tech, I could see that out west in that area that it was really more open. And I think at one time when I became department chair, we had quite a few women. So I think the ratio was that 30% women and 60% men. But the second or third year after I became department chair, the freshman class were all women in their 30s coming back for I couldn't believe it.
coming from the industry.
From other industries to come get a mining degree. All of them, every single one of them. They were anywhere from 30 to 40 years old. And I was just proud as punch.
Yeah.
And I thought, wow, you guys really know what you want to do. They did amazing girls, just amazing women. So it was coming. It's coming,
Mhm.
but it's coming. But anyway,
What were some of those other impacts that, before you going into being a professor, were there struggles in academia as well?
no, absolutely not. And that's why I chose New Mexico Tech. I interviewed at all the mining schools. Colorado School of Mines never even responded to my. They never even bothered. Rolla, same thing. Believe it or not. A lot of the other schools, Penn State, of course, wanted me right away because they needed women. And there were a lot of other places that were very open. So I did interview. But when I went to New Mexico, the atmosphere was really open and very kind and very generous. And they had housing for me. The wives came to a dinner, not just the men. And it was very family oriented. And I just fell in love with the place. They also had their testing facility, their explosive testing facility, EMRTC it was called, Emertech.
Still one of the
It's still there,
best in-
absolutely.
best in the nation.
And
in the world.
the New Mexico had quite a bit of mining. It was new to me. And the faculty were just amazing. And they offered me more money than any of the other
Well,
schools.
there you go.
$28,000 opposed to 21. So I said, I'll take it.
Yeah.
And I never looked back. And I loved it. It was just a place where they let me I answered to 2 vice presidents, and that was it. Very small administration. They let me do whatever I needed. The president was in my office every other week saying, Cathy, what can I do for you? It was amazing. Los Alamos, Sandia National Labs, a lot of opportunity there. And it just grew. So we started the explosive program between mechanical engineering and ours and chemical. We had Dr. Per-Anders Persson there
Mhm.
helping us to develop emulsions. So it was a wonderful time. And I'm glad I went there.
Wonderful. Okay. And once starting out and developing, because you were developing that explosives program there, and that's not an easy task in itself. I mean, so you had students immediately joining, they were wanting mining, but I guess your background now is explosives influence.
Right.
What made
exactly.
you want to focus more on the explosives and create that program?
The demand was there, the demand out of industry. Vulcan Materials gave me a big down-the-hole hammer, and we had a drill rig. We had an experimental mine. So when the students would come for the undergraduate, because mining was big then, and we had quite a bit of input from the Navajo Nation. The Navajos would come. We'd have about 10 of those students out of maybe 150. And so there was quite a diverse group of people from both out of state and in state. We probably had 150 students when I first came there. And so we started an explosives course in the undergraduate.
Class.
One class. That was it. That's all we needed. And they loved it.
Who would?
But I'm one of the people who like to take people in the field. I don't teach in the classroom. I teach out in the field. And I think that really helped too, to stimulate the interest. So a lot of students decided to stay. And the master's program, we got it down so that they could take some of the courses in their senior year and then just stay for one extra year. And that was it. And so the students were in demand. Just like as Rolla in Kentucky, we were all doing, I think there was probably, 5 of us that were really emphasizing explosives. But the industry needed that at that time. And it worked out very, very well. So we never did go to a PhD program. We stayed with just a master's student program, I'm sorry.
What were some of the, who, let's say, were some of the big influences on helping that situation?
With regard to industry, you mean?
With regard to industry and maybe potentially through, I don't know, other forms of mentorship. You already mentioned Chuck Downing, but
Oh yeah,
are other people
definitely.
there that were instrumental in helping that?
Well, I think the mines themselves. I mean, if you really look at who was taking the students and why they were taking the students, we would have a senior research project that they wanted. And so that was when Phelps Dodge, it was called Phelps Dodge, now it's Freeport McMoran, opened up their doors. And some of the coal mining industry needed help on timing. There were so many needs out in West at that time that we just, well, let's just roll up our sleeves and go do it. We had the equipment then, we had better high-speed cameras, and we had better diagnostics. And the students got to get involved in a lot of the research projects that we had. And so I think if I can't think of any one person, it's just the acceptance of the students out in industry to do these projects, to use their mind as a playground, if you will, so the students could get their degrees. But we helped them too, because we improved their fragmentation and DAC break. That was our two big goals. And I think we probably graduated about 35 or 40 students over about a 10-year period, and they're all doing very well.
And that was including a lot of the women as well. It didn't matter at that point. Now it was,
No.
you'd broken the ground.
It was amazing.
People were going.
Yeah, no, they all were it was amazing. They're all doing very good. They're mine managers now and head of mining programs, and also work for national labs and high-level research projects. I'm proud of all of them. They're all retiring now, and I'm still working. Right?
Good for you. Keeps you young and working, that's
Yeah.
for sure. So was there, I guess it's kind of an interesting topic that I don't really have too much of these interviews about. So do you still see certain hurdles, as someone top of your field in the industry, that you're still being, the gender is still a thing, and you're just like, just listen to my data here, please, instead or is that long gone? No?
Yeah, I think it is, because I think just having a PhD and just having a resume with a lot of research projects, once they look at that, they go, oh, wow. The kind of research we're doing with national labs, as well as down to mining companies and so forth. And we got into ATF work, disposals, and all kinds of demolitions and things like that. We really broadened the program. No, I think your resume and your reputation goes really far. I mean, it goes fast. Now, I did give a talk the other day to women in tunneling. Now, the Society of Mining Engineers, SME, has a lot of spin-offs. And one of theirs is, I didn't even know about this, women in tunneling. Because I'm working in New York, upstate New York, on water resources, bringing in more water from the Finger Lakes, working with a consulting firm. And one of their secretaries, or not secretaries, one of their engineers said, can you give this talk? It wasn't a podcast, it was a talk. And I thought, what's women in engineering? So I started looking up their membership, and they're girls that I've been working with, young women. And I'm thinking, and then I started reading that they are still having problems sometimes in tunneling underground. Same thing. I think it's still hard to kind of prove yourself and get into the positions where you make more influence on rock mechanics and time and costs and that sort of thing. But it's coming slowly. But I can see there's still a little bit of resistance. Depends on where you are in the United States. Back east, in particular, it's a little tougher with the unions.
When it comes to, going into academia, and, I feel like a lot of students, they want that. They're whether it's a master's, but then they might, you can correct me if I'm wrong, sometimes there's a struggle to find a project that justifies a PhD. Maybe a little easier for the master's. But how is industry nowadays? Is that same level of need and want from the industry when you were starting out? Does that still exist, or is it a different attitude towards getting the PhDs and doing those studies, or is it more difficult?
I think you're hitting on something that's very important. And I reflect on that over the past 20 years or so. You're right. I think it's the need from industry. If you look at the explosives arena, if you will, a lot of the advances took place in the 60s, 70s, 80s. And we now have electronic detonators. We perfected the timing. We've perfected explosives. The explosives are amazing nowadays with the amount of energy that you can tailor make.
Yes.
And the question is, can we get any better? So at the time, now, to get a master's degree is pretty much easy, but a PhD to get something unique with an industry that really isn't advancing, because I think we've pretty much hit
almost a plateau.
Exactly. So the question is, what can you do for a PhD? Because it's got to be original. It's got to be something that nobody else has done. And that plate of opportunity is shrinking. There's just to me, unless we get into something with AI or some high-end,
Computation.
something like that. I really don't see that there's a lot of opportunity for PhDs at this time. Probably there is, but I don't know how many PhDs are working now in the schools. I know we stopped even looking at the PhD program.
Wow.
So we just couldn't sustain that with the industry. It's very important for me, if you have a PhD program, you've got to work with industry. You can't just work alone on computer modeling that you hope somebody is going to use. There's got to be something that's generated, the idea is generated from industry. And I just don't know if we're able to do that at this time. Maybe I'm wrong.
Is does the industry feel that as well, or is the industry coming to you with more problems, or are they trying to keep that more secret?
No, I think you're right. I don't think I'm now that I'm not teaching, I'm not in that area now. I'm just not sure if industry knows what they need to do. I don't know. It's not a cost thing. It's more of an I guess it's a cost thing, but efficiency. I'm not sure. More of a. I don't know how you want to say this because I'm not into this sort of thing, but I think it is taking the whole mining operation, of which rock blasting is just one small component, and making the entire process more efficient. Now, does that constitute metallurgy and the crushing and the leaching and all that sort of thing, the slope stability and all those things? I mean, is that something that I think
really tying in the mine to mill process?
Exactly. I think with the instrumentation and that kind of data sharing amongst the different components, because mines have so much, they're very complex. So I think making the operations more efficient, which is cost, of course, and how blasting plays into that. I'm not sure. I'm not sure this time. There probably is a room, but for a PhD thesis, I don't know. I just don't know.
What are you kind of projecting the future of academia's relationship with mining? You said that you're not doing PhDs anymore. There is a struggle. We might have hit a plateau. You mentioned maybe when it comes to AI, but what do you see as potential for someone to be studying in when it comes to maybe vibration or that relationship? Do you look towards the future and say, oh, this is an avenue someone might be diving into?
Well, I really think the management area is really where we're going. I think that's what we need. We need to educate students in all aspects of mining, and not just blasting. I mean, blasting is one part of it, but the management part. I don't know how to say it.
How to deal with nerds like me.
Because it's tough. No, I'll tell you, it is tough because we've been asked to come as a team with other universities and that sort of thing out to industry that has problems. Most of the problem is communication. Most of that. A lot of the mining companies, I see some of the big ones, they'll take somebody from college and keep them in one area for 6 months or 8 months and then move them to another area, and they keep moving them around. Every time they move them around, they have to develop relationships with that group. That is very, very difficult to do. I don't know if that model is the right model, but the mining industry thinks that's the way to develop their managers.
They've been doing that for a very long time. And I used to work for a powder company, and that was one of our biggest struggles is you're using the explosives role as, almost the second lowest ranking person.
Absolutely.
And you had survey was the very first one, and right after survey or sampling, it was then explosives, and then after that it was all these other things. So as the explosives company, you were almost also helping train that person as the contact. So now you're giving free training, it's part of the business, but then, like you said, 6 months later, you got to start over with a whole new person. All right, here's your burden and spacer. This is why we had a misfire. This is and they almost they weren't even in the position long enough to observe the changes that they were making in their pattern design.
Absolutely. No, I agree 100%. Then they have to go to the whole mine, then it blows up. It goes into short range planning, mid range planning, long range planning, and then you're dealing with all you lose that identity, you lose that ability to really perform in one particular area. Yeah, I agree.
And then they're paid a lot more in long range than they were in explosives. So
exactly.
they want to take that zap
exactly.
out of there.
Exactly.
seem to think that there is still, we just aren't aware of how much more we can improve with explosives.
Exactly.
As this technology changes with gassing
Yep.
at the end of the hose, new types of chemicals that are being implemented
Exactly.
to reduce post-blast fumes.
Yeah. How
there is so
much more is there to learn? Exactly. I agree 100%. I see a lot of too. I don't know about other parts. I'm not sure exactly what the explosive industry is doing right now, but there's just so many explosive suppliers do the loading and the it's service, shot service. So much of that technology is moved away from the mine site itself back to the explosive suppliers, and I guess, and so I think the onus is on them to really look at. But are they prepared to look at optimization? And usually the mining companies will do their own drilling. I guess that's what I see now.
Especially the big mines.
Exactly. Yeah. They do their own drilling, and it's all computer controlled and that sort of thing. And but does the supplier who supplies the explosive, is there enough feedback from the two work together to make that optimization take place? I just don't know how much if you separate drilling from the explosive part, are you really optimizing the system that way? But a lot of mining companies just don't load the holes anymore.
Yeah.
They just have a company come in and do it. So I don't know if that process is the right model. I don't know. It probably is for certain operations.
That's a good point. Now, what advice, or before I go into the advice, what would you consider maybe one of your biggest mistakes have been in your maybe in teaching, or do you feel like you look back and say, if I wish I would have done this a little differently?
That's a good question, but I can't think of anything that I would have done differently. I hate to say this.
No, that's an awesome.
I hate to say this.
That's how you know you're doing things right.
No, because our kids were all well received by industry. They were in demand. I don't think I made any mistakes that I'm aware of, because we were pretty. My attitude was we'd go to the mine. We'd let the mines come to us. We didn't go to them. They would come to us and say, "We have a problem. Let's see if we can solve it." So we did. And a lot of the work that we were doing, once we were done with the fragmentation and the optimization and the cost and that sort of thing, we started to look at structure response. And so that was probably, I think we abandoned what was taking place at the mine itself, other than controlling vibrations and air overpressure. And then we're going to, and that's when OSM came, I think, the OSM came to us with a structure response study. And then I started looking offsite. What were we doing to the community? And looking at different structures. And I think that's when OSM said, well, the Bureau of Mines structure response study, can we improve on that? When the Bureau of Mines did perform 8507, they looked at only mine structures, old mine structures in Indiana. That was it. So the Z-curve was based on one type of construction for one type of geology. And that's where they started to look and say, well, what about other types of geology? So they came to us in structure response. That's when we started to look. We left the blast site, the blasting bench, and went to instrument structures. And then I realized that symbiotic relationship between blasting and the offsite impacts at 1,000 feet, 500 feet away. We realized that maybe we hadn't quite finished our job. And so that's where I think it was a 2 or 3 year study. And we looked at other types of structures beyond which the Bureau of Mines did not study. They studied, I should say. And we went all over the United States to look at all types of structures. I learned a lot from that. And I think the fact that we were exposed to different geologies made a huge difference in the way we looked at blasting. And so I think it broadened our perspective.
Okay. And when it comes to now the question on advice, what type of, let's say, character trait or attitude should you have going into some of these types of studies, or how to view a very significant situation, like, the government telling you to do one thing and now you have to prove that? What's some sort of advice that you might have to our listeners on how to, if they're dealing with a struggle that could be as significant as that?
I think just to keep an open eye, open ear, and listen to everybody, listen to what everybody is saying. And there you're coordinating people, you're organizing people, you're getting people on the right track. So what kind of study can we do to appease everybody, to answer all the questions for that? I think just having a broad, and I think we've had to do that in a lot of studies where a quarry wants to open a quarry, and they've got to do some test blasting, and we've got to prove with the blasters that they can mitigate the offsite impact. So it really isn't just optimizing on the blast itself, but looking at what it's going to do to the community, because the regulators and lawmakers are watching. They're watching, and it's working with the blasters. I think getting down and dirty with the blasters to show them that in order for you to develop this quarry or this mine or expand this mine, that we've got to really look at what's happening offsite. And they don't think about that. I mean, they've got blindfolds on. They've got, and they just want to make a good product.
Get to work.
Absolutely. Yeah. But I think it's training the blasters to understand what they're doing and what kind of impact it has. And so it's really a team effort. It's a vision to take that vision beyond just loading a hole and understanding what's going on in the air and in the vibrations. So I think education is important.
Okay. Well, Thank you very much, Cathy. Again, I appreciate you coming on the show. I really do. There's always so much to learn, and I'd like to have you back again.
Thank you very much. I appreciate what you're doing.
Thank you for listening to this episode of the Blast Report podcast. I want to thank the team at Blast Think for producing this show, and please follow along for more episodes in the future, and share this podcast with your colleagues so we can continue to honor our industry and the people in it. Be safe and have a blast.